All right, everybody, we're on lesson 14, which is multiply fractions using an area model. Our example problem says, what is 3/4 times 1/3? The number line is divided into thirds. We can see that here. Here's 1/3, 2/3, 3/3. Each third is divided into fourths. So here's 1/4, 2/4, 3/4, and then 4/4. Each of these parts is 1/12 of the whole. So here would be 1/12, 2/12, 3/12, 4/12, 5/12. So there are 12 of these parts here. 3/4 of 1/3 is shaded. The whole is divided into twelfths. We just saw that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. With 3/12 shaded. So here are 3 of those twelfths shaded. So 3/4 times 1/3 is 3/12. So our first question says, why is the shaded rectangle above the number line in the example divided into 3 parts? And the answer is that you're finding three-fourths times 1/3. So it is 1/3, and it's divided into 4 parts, and 3 of those are shaded. So what that means is these 4 have been divided. So here's our third. So here's our 1/3. It's right here. And then it says it's being multiplied by 3/4. So we have our 1/4, 2/4, 3/4, 4/4, and we have our 3/4 right here, and it's shaded. That's what that means. So problem number 2 says, how would the model in the example change if the problem was 3/4 times 2/3? Well, we would have to add another one of these rectangles with the 3 shaded areas, because our first one said 1/3, so that's this area right here. So if it was 2/3, we'd have to have another one shaded in. So we would add another rectangle with 3/4 shaded in. So in problem number 3, we actually get to model this. So it's going to look really similar to our example up on top. So we already know what that part looks like, and you all know I'm not a very good drawer, but I'm going to try. So here is the first one, and we have it separated into thirds. And then the next one's just going to come right over here. So here's the first one for the 1/3, and 3/4 of it is shaded in. Here's 1/4, 2/4, 3/4. And the next one's going to start right here, and we're going to do the same thing. So we have 1/4, 2/4, 3/4, and we're going to shade them in using whatever color you choose. I'm going to use yellow. So if I'm shading these in, I'm going to count them now to see how many total we have. 1, 2, 3, 4, 5, 6. So 6 total. And now I'm going to count how many there are in all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 in all. We have more modeling questions, which I happen to love these modeling questions. It says, look at the model and answer the following questions. Each column is what fraction of the whole? And remember, the columns are up and down like this. So I'm taking my pen and I'm modeling for you that each column there are 3 of them. So if I'm looking at just one of them, it is 1/3. And it actually says it right up here at the top. So it's 1/3 of the whole. Each row is what fraction of the whole? So I have 1, 2, 3, 4. So if I'm looking at just one of them, like this one right here, it would be 1/4. So how many parts are in the whole? So I'm going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That just means each little section right here, if I broke them all up, there would be 12 total. The dark part shows 3/4 of 1/3. So that's this part right here. So when you crisscross them all, what fraction of the whole is 3/4 times 1/3? Well, I see 1, 2, 3 out of, and we already counted, there are 12 total. So 3/12. So what's the product of 3/4 times 1/3? And we could say it is 3/12. Now I could go ahead and reduce it. I could divide by 3 for both of these. 3 divided by 3 is 1. 12 divided by 3 is 4. And I could say it's 1/4, but I could also leave it here and say it's 3/12. Number 5 is another modeling question. It says shade and label the model to show 3/4 times 2/3. Then complete the equation. So sometimes we have trouble figuring out which one is going to go up and down and which one's going to go left and right. But I'm going to look right here at the denominators to find which one is going to go on this side over here. So I'm going to look and see how many times it's separated. 1, 2, 3, 4. So I know automatically that my 3/4 is going to go over here because it's separated 4 times. So I'm going to shade my 3/4 in blue. So I have 1/4, here's 2/4, and here's 3/4. And I'm just going to kind of remind myself that this right here is 3/4. And I'm going to do my 2/3. I'm going to do it in purple. And that's going to be up and down. I could do it over here or I could do it over here. It doesn't matter. So 2 out of my 3 are going to be in purple. And up here, that's 2/3 because I still have 1/3 over here that hasn't been shaded. So how many are shaded in both blue and purple? 1, 2, 3, 4, 5, 6. And how many do I have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But I want to show you guys something else that's pretty cool. 3 times 2 is 6. 4 times 3 is 12. Now could I go ahead and reduce it? Of course. I can divide by 6 for both of these and get 1/2. All right, problem number 6 says 6/12 is equal to 1/2. How does the model you shaded in problem 6, that's this one right here, show that? Well, in problem number 6, the dark part has 6 shaded in. And there are 6 that are lightly shaded in. So what I mean is 6 have both colors, and there are 6 that have either no color or just one color. So that's showing that half or an equal part have both colors, and there are the same amount that have no colors. So when you add them together, 6 and 6 makes 12. the darker part is half of the whole. I love problem number 7 because we get to be creative. It says, write a fraction from the box to complete the expression, then complete the model to show the problem. So it already has 1/5 shaded in for us, and all this is already done. And then we can choose 1/2, 1/3, or 1/4. So I'm going to go ahead and do 1/4. So I'm going to cut my model in half. That's showing 1/2. Then I'm going to cut each half into a half again. So right now I'm showing fourths, but I have to shade in my 1/4. So I'm going to do that using my pink from earlier, because I still have that out and open. So right now I only have one box. So I have 1/4, that's the one I decided to use in my example problem. So 1/4 times 1/5, and that gives me just one tiny part that has both colors in it. Out of how many total boxes, if I counted all these up, I would find that I have 20 total parts. But I can also see, because we now know and understand fraction multiplication, 1 times 1 is 1, 4 times 5 is 20. And here it is modeled for us.